right, so let's figure out how to control this motor direction. You may have already figured this out from previous videos, but it's just good to go over in more detail because there's a lot in previous videos. So to start off with, we're starting with a basic circuit. You've got my hokey drawing circuit here. Notice power set up. We got power supply to the motor, VCC2, set to 9 volts, like our battery pack. We got the power supply for the internal chip logic, which you don't want to burn out. It does not need a ton of power to just 5 volts coming out of the Arduino. And then we got at least one of our guys connected to ground. In this case, we're probably going to want 2, remember. One connected to the ground of the Uno and one connected to the negative side of the battery pack. Now, if the Uno was being powered by the battery pack, you wouldn't need to do that. You could do it with one connection. But in this case, you should have both. All right, or connect your grounds. You can also connect your grounds. That'll work great too. Okay, so if we check out our circuit, our Y pins, by the way, one important thing to remember, never connect these Y pins to the Arduino. They can put out 9 volts. The Arduino, only one pin on that whole of all those things in the Uno can handle 9 volts. And odds are it's not going to be the one you connect it to. So why would you ever connect a Y to the Arduino? Because there could be smoke if you do. If it's active, this would put out 9 volts and could totally burn out your Uno. So careful of that. Why would you ever connect a Y to the Arduino? Also, A's go to the Arduino. A for Arduino. Little remembering. Okay, so if you remember, if 1A is high, if it's 5 volts, that means 1Y gets the full battery supply voltage, which in this case is 9 volts. And if 1A is low, it's ground, it's 0 volts. Same thing with our 2A and 3A and 4A. If 2A gets 5 volts, if it's digital written high, then 2Y will go to plus 9 volts. If it's digital written low, if it's 0 volts, 2Y will also be 0 volts. So I set this up in this way just because we're going to look at the zoetrope code. So if we look at our zoetrope code, we're just going to look at the control part, like the direction control. Oh, by the way, remember, if one of these is at plus 9 volts and the other is at 0 volts, you'll have a voltage difference, which is important. If they're both 9 volts, it doesn't do anything. If it's both 0 volts, it doesn't do anything. But if through messing with these A pins, you set one to 9 volts and one to 0 volts, current will flow through it one way, and then the motor will turn that one way. If you switch which one's 9 volts and which one's 0 volts, current flows the other way, and it'll turn the other way. So let's see how the code works in the project book. So if we look at this, we got 2 control pins set up. Notice in the circuit I was showing you, pin 2 was connected to A1, and pin 3 on the Arduino was connected to A2. So yeah, A1, A2, and these are the pins in the Arduino it was connected to. This is kind of related, direction switch pin. It's just the pin on the Arduino that a switch in the zoetrope thing, where if you press it, it changes direction. So that's just the pin on the Arduino connected to that particular switch. And then we also have a direction switch state and a previous direction switch state. Just to deal with, like, if you press it, we're going to be toggling a value, and so you only want it to change states once. So kind of important. And here is that state value. You only want to change one time when you press that button. So motor direction is going to determine if we're setting A1 high and A2 low, or if we're setting A2 high and A1 low. So that controls that. And these switch states are what we're going to use to flip motor direction from a 1 or a 0, a 1 to a 0 or a 0 to a 1, depending on what its previous state was. Just change it. All right, so we've got some pin mode setups. You can probably figure that out. So our direction switch state is going to be equal to the digital read of our direction switch pin, so either high or low, 1 or 0. By the way, in C++, a 1 is equivalent to true, and a 0 is equivalent to false. So we could mess with some of this and make it a little simpler. So here's our other direction code. Oop, too close. So if the direction switch state is different from the direction switch state last pass through the loop, so it's just changed. So you've either just pressed the button, it was low before and it's gone to high now, or you just released the button and it's gone from high before to low now. So that's in this first if statement. That's what it's checking for. Now that's two occurrences every time you press the button, so we need to do something else. And so the next thing we check for is the switch state high? If the switch state's high, that means it was low before, now it's high now, we just pressed the button. So it's these two together are looking for a was the button just pressed? If I were going to do it, I wouldn't do two nested or a nested if statement. I'd just do if direction switch state does not equal previous direction switch state and use the and operator. I could just use direction switch state because that on its own is a true or false. So I could do the equals high, but the equals high is unnecessary. This is some great code right here. I really like this. This is saying, hey, because motor direction is either 0 or 1, true or false. So it's saying, hey, make it the opposite of what it was before. If it was 1, make it 0. If it was 0, make it 1. So that's what motor direction equals not motor direction means. It's great if you've got some Boolean value, some true-false value, and you want to switch it to the other one. Whatever was before, make it the opposite. If it's turning this way, make it turn that way. You get the idea. So, and then we got a if-else thing here that handles controlling the direction. We need A1 high and A2 low, or A1 low and A2 high. So if motor direction is true, if it's 1, by the way, this equals 1 is unnecessary. It's either going to be effectively true or false, 1 or 0. And so it's true or false effectively on its own in C++. So you could just do if motor direction. So if it's supposed to be turning one way, digital write A1 high and A2 low, and it'll turn that direction you want it to go. Otherwise, if motor direction is 0, if it's false, digital write A1 low, make it 0 volts, and digital write A2 high, make it 5 volts, and then it'll turn the other way. Yeah. And that's how it works. This whole business right here just says, hey, set it up for next time. I want to save the state the direction switch was in this pass through the loop as previous direction switch state, so it's ready for next time. So I can compare, like, did it change between last pass through loop and this pass through loop? Because if it's different, it's just been pressed or just been released. And so that's why that's there. All right, that was a bit long, but thanks for listening.